Alright guys, today we're going to look at parallel and perpendicular lines on a coordinate plane. You can see to the left here I've got a couple of notes. There are two kind of distinguishing characters about parallel lines. First off, they have the exact same slope, and second off, they're never going to intersect because of that same slope. And so I want to kind of show you, just looking at these two lines, how we can distinguish that they are indeed parallel. So if you look at the top line here, what you can do is you can look at the slope of this line by calculating your rise over run. Slope does equal that rise over run, and rise being kind of up or down, and then run being left or right. And so, like, if I start at this point right here, and I can count and calculate the slope, it goes up 1 and then right 2. And so up 1 indicates a positive 1, and then right 2 is what happens here, and that indicates a positive 2. If it was down, it would be negative, and if it was left, it would be negative. And so the slope of this line is 1 over 2. Okay, and then you look at the other line, and all I have to do to prove these are parallel is to prove that it has the exact same slope. And so again, I can pick a point, I can count my rise over run, and see that my slope of this line is also 1 over 2. So these two lines would be parallel, and they will never intersect. And there's a lot of different applications with this. You could write equations for these lines in slope-intercept form. You can do a lot of different things with it. So let's take a quick look at perpendicular lines. Perpendicular lines have two similar principles, but they're actually exactly the opposite. First off, perpendicular lines have what we call opposite reciprocal slopes. And opposite reciprocal slopes has kind of a dual meaning that is important. Opposite, when it talks about that, it's talking about opposite signs. So if one of your slopes is positive, then the other slope would have to be negative, or vice versa. And then the idea of a reciprocal is basically where you take a fraction and you flip it on itself. The numerator becomes the denominator, and vice versa. And so again, going through the same, calculating the slope using my right over run process here, I can start with this line here, and I'll place a point, and I'm going to count up 1 and then right 3. And so the slope of this line is 1 over 3. Okay, and then I can go and look at the other line, and I'll use this point here. This time I'm actually going to count down 1, 2, 3, down 3, and right 1. Well, that's a negative 3 over 1, which is the same thing as negative 3. And so the slopes of these lines, we would say they are opposite reciprocal slopes. One's positive and one's negative, which that's the opposite part, and the reciprocal part is that the fraction has been flipped. So we can verify these lines would create a 90-degree angle, and they are perpendicular lines. And so again, a lot of application here, a lot of different things you can do with that information once you understand that. Two perpendicular lines create 4 90-degree angles, which are significant. And again, there's all sorts of equations, slope-intercept form equations you could do with that as well. And so this has just been an introduction to parallel and perpendicular lines.